Hello everyone, welcome to on my YouTube channel Dr. Prashant Vedi Physics classes. Today I discuss about the De-Broglie wavelength. Any particle, material particle moving with velocity, moving with velocity, moving with velocity also having the wavelength lambda or then the momentum also p. The De-Broglie hypothesis is the every particle with momentum p and mass associated with the wavelength lambda, and De-Broglie given the hypothesis and wavelength is given by the relation lambda, it is equal to h upon p. H, it is equal to Planck constant. Given the wavelength given by a particle is given by lambda, it is equal to h upon p. H, it is equal to Planck constant, and p it is equal to momentum. Then lambda, it is equal to h upon mv for material particle. For material particle, equation number 1. According to the Planck theory, E, it is equal to h nu. Then equation number 2. The Planck theory, energy of the photon E, it is equal to h nu. Nu, it is equal to c upon lambda. Then E, it is equal to hc upon lambda. Equation number 3. According to the Einstein mass energy equivalence relation, E, it is equal to mc square. This is a well known formula, Einstein mass energy equivalence relation. Equation number 4, and which is also energy, and equation number 3 and 4 equating. From equation 3 and 4 equating the mc square, it is equal to h c upon lambda. Then lambda, it is equal to, एक c से एक ये c कैंसिल हो जाएगा, lambda it is equal to h upon mc. For a ये देखिए क्या है, एनर्जी लाइट पार्टिकल है, लाइट पार्टिकल के लिए क्या है, लैम्डा इट इज इक्वल टू h अपॉन mc. फॉर ए मटेरियल पार्टिकल, देन c इट इज इक्वल टू v. लैम्डा इट इज इक्वल टू h अपॉन mv for a material particle. Then the 3 cases is there. First cases is the particle is to be a kinetic energy. Then E, it is equal to 1 upon 2 mv square. 3 cases is there. First is a particle is having the kinetic energy E, it is equal to 1 upon 2 mv square. then multiply by the m numerator and denominator. E it is equal to 1 upon 2 m v square into m upon m. तो यहां से ये E इट इज इक्वल टू m स्क्वायर v square upon 2m. We know that also P it is equal to momentum, it is equal to mv. Momentum it is equal to mv. Then E it is equal to P square upon 2m, or P it is equal to under root 2me. P it is equal to under root 2me, और E it is equal to क्या है? E it is equal to काइनेटिक एनर्जी. तो फ्रॉम इक्वेशन नंबर 1 से ये वैल्यू यहां P की फ्रॉम इक्वेशन नंबर 1 से क्या आएगी कि लैम्डा इट इज इक्वल टू डी ब्रॉगली वेवलेंथ के h अपॉन अंडर रूट 2me. तो विच इज द फॉर्मूला इक्वेशन नंबर 5, विच इज द फॉर्मूला फॉर डी ब्रॉगली वेवलेंथ फॉर द काइनेटिक एनर्जी. E it is equal to kinetic energy of the particle. Equation number 5. Second condition, relation between wavelength and temperature. When a particle in the thermal equilibrium, then the kinetic energy of the particle which is equal to 3 upon 2 kT. When a particle, relation between the wavelength and temperature, the particle in a thermal equilibrium, then E kinetic energy of the particle E it is equal to 3 upon 2 kT. So this value, equation number 6, this is the value put in the de Broglie wavelength. Lambda h it is equal to lambda upon under root 2me. Then lambda it is equal to h upon under root 2m, और E ये काइनेटिक एनर्जी इंटू 3 अपॉन 2 kT. तो 2 और 2 ये कैंसिल हो गया. लैम्डा इट इज इक्वल टू h अपॉन अंडर रूट 3m kT. तो विच इज द रिलेशन बिटवीन द वेवलेंथ एंड टेम्परेचर. इक्वेशन नंबर 7. एंड थर्ड कंडीशन इज कि व्हेन पार्टिकल moving with the potential V, particle moving with potential V volt, then kinetic energy which is equal to the gain kinetic energy by the electron, then kinetic energy E it is equal to EV, which is the work done, which is equal to the kinetic energy, it is equal to the gain the kinetic energy. Then from equation number this de Broglie wavelength which is comes lambda it is equal to h upon under root 2me So which is the third conditions? Equation number 7. De Broglie wavelength, it comes lambda is equal to h upon under root 2 m ev. For the particle moving with the potential capital V volt of the matter wave or De Broglie wave. First point is the lighter is the particle, greater is the wavelength associated with it. Lambda it is equal to h upon m v. ये जो वेवलेंथ है, वेवलेंथ ऑफ द De Broglie wavelength, lighter is the particle, greater is the wavelength. लैम्डा इट इज इक्वल टू एच अपॉन एम बी, क्योंकि अपॉन में ही ये अगर एम इज लेटर देन होगा, लाइटर होगा, तो ये क्या होगा कि ये वेवलेंथ इज ग्रेटर देन. सेकेंड इज द स्मॉलर इज द वेलोसिटी ऑफ पार्टिकल, द ग्रेटर wavelength associated with the lambda which is also greater than. Third point is the matter wave is generated only when the material particle are in the motion. And fourth point is the velocity of the wave, matter wave depend upon the velocity of the material particle. And fifth point, which is the De Broglie wavelength, De Broglie wave are not the electromagnetic wave. And last is the velocity of the De Broglie wave is greater than the velocity of light. Thank you.